Confidence intervals are a very useful way for understanding an interval in which we would expect a certain percentage of values to fall between. When we're looking at confidence intervals, we can have multiple different types. The first one we're going to look at is a confidence interval for a mean with a known standard deviation. The standard deviation is considered known when it's calculated from a population versus a sample. When it's calculated from a sample, then the standard deviation is considered to be unknown, even though it is actually calculated. So in this example, we're going to calculate a confidence interval using a known standard deviation. In this example, we have a random sample of 25 items that is drawn from a population whose standard deviation is known to be 40. So again, in this case, it's considered known because we're using information from a population to calculate our standard deviation. The sample mean is X bar, our average, which is equal to 270. And we can use this information to construct an interval estimate for our mean, our mu, with 95% confidence. So our equation for our confidence interval will be our average plus or minus our z value for alpha over 2 multiplied by our standard deviation divided by our square root of n. So using the information that's been given to us, we know that our value for n, our sample size is 25. Our x bar, the average was 270. Our standard deviation was given to us as 40. And then our z value will be 1.96 since we're looking at a 95% confidence interval. As we look at our equation, we're going to start with our x bar portion. And we have our average. It was given to us as 270, and that's in cell B16. The second portion of the calculation then will be calculated as our B18 value, which was our z value of 1.96, multiplied by our standard deviation, which was in cell B17, divided by the square root of our sample size, which was 25, and that's given in cell B15. So our confidence interval is 270 plus or minus 15.68. We can use that then to calculate more of our range by taking our mean minus the second half of the equation to get our lower confidence interval of 254.32, and our upper confidence interval is our mean plus the 15.68, or 285.68. So we can say with 95% confidence that our values will fall between 254.32 and 285.68 when it comes to the numbers that we're looking at here. Now, one thing that I want to point out is that anytime we're talking about confidence intervals, because of our denominator, our interval relies heavily on our sample size. As our sample size becomes bigger, then our confidence interval will become smaller. However, the smaller the sample size, then the wider our confidence interval, because we're trying to capture with a certain level of confidence, typically 95%, that all of our values will fall within that range. So our calculations are extremely heavily based on our sample size.